y'all, Miss Brown here, your 8th grade pre-AP science teacher. Okay, y'all, so we're gonna do our snack tectonics lab. Ooh. And we can't really be passing around supplies and all that jazz, so I will do it as a demo, and y'all will be filling out your trusty dusty journal as you are doing it. So y'all are gonna go to page 16 in your journal. So it's the page we skipped before, right after the cover page for topic 2. So what I want y'all to do first is I want you to split up each of these into 2 rows. So something happened when we transferred it, and it should be asthenosphere is 1 row, oceanic crust is a row, continental crust is a row, oceanic ridge is a row, convergent, then subduction, then divergent, then transform. Fault should really be, as I'm noticing it now, fault, and then trench. So separate those out, and then mountain range and volcano. So I'll give you a minute to get that set up. And if you want to do the lab at home, the materials that y'all will need are right down here. So pause and get that set up. But I'm going to keep going because this is real life. So y'all, boop, pause me and get this done. Okay, y'all, so let's get set up. So what I want you to do after you get this set up is I want you to take a minute. So pause me again when I'm done. And I want y'all to write as much as you know about those topics. So what's the asthenosphere? What is the oceanic crust? So remember, y'all, I talked about my girl Billie Eilish and a grandma. So Billie Eilish is young. So continental crust, like grandma, is old. So continental crust is old, brittle. Think of like grandma with a cane. She's so fragile. And then you have Billie Eilish, young, dense, so very tightly packed. So that helped me remember because I think old people are wise and brilliant, and us young people, like I'm grouping myself in, I'm like kind of in the middle. Y'all young people are a little dense, you haven't got everything figured out yet. So that's why I say that continental crust is old, brittle, kind of frail, but it's less dense, so it glides on top of the oceanic crust. Whereas oceanic crust, like Billie Eilish, Ocean Eyes, is young, dense. So ocean crust is younger because it's made when the ocean plates or the ocean crust diverges, and then you have that molten lava that comes up and forms that hard kind of new ocean crust in the middle. So continental crust, y'all, has been here since the beginning of time, and oceanic crust is constantly kind of recycled. So take some time to kind of go through each of these. Tell me what a convergent boundary is, what subduction means, what divergent, transform, fault, trench, mountain range, and volcano. And remember, y'all can rewatch my videos that I review all the different boundary types. It's about a half-hour video, and if I remember, I will link it in the corner. So pause me and fill this out. But like I said, y'all, I'm going to keep going because this is real life. Okay, so I'm going to kind of scoot myself down a little. So y'all are gonna need graham crackers. You're gonna need some kind of pudding. It doesn't matter what. I've got a dark chocolate and a regular chocolate. You can use vanilla. Use whatever you want. Use frosting. Doesn't matter. And y'all will need a few fruit roll-ups if you want to do this. If not, just watch my demo. So I have 2 fruit roll-ups because when you get to the end of the fruit roll-up, it kind of gets stuck and it's hard to pull out and it doubles up. So you need it to be thin. So I grabbed 2 of them so that way I can cut them up, which I'm going to go do right now. I'm going to go grab some scissors. Okay, so I'm going to cut like a piece like this. So cut my fruit roll up in half, but make sure that it doesn't get stuck up on each other. And then I'm going to cut this one in half. You can use whatever you want. Please use safety if you're doing this. Ask parents for help if they don't let you use kitchen supplies on your own. So I have my 2 pieces. I've got a couple graham crackers, and I've got a couple things of pudding. Okay, sweet, y'all. And I have my stuff sitting on a piece of tin foil. You can use wax paper, your counter, paper plate, something like that works just fine. Y'all, I feel so short. Okay. So we are going to start, after y'all should have filled this out, kind of what you know about each one without really looking. Then you're going to turn the page And y'all are gonna pause me again after I'm done explaining this, okay? So I want y'all to write this stuff. So pause me right here so that way you can copy it down. Pause me! Okay, so y'all should have added a 5th row right here. And then you should have copied down these parts. So the type of boundary include the name, and then whether it's continental or oceanic. So you should have paused me and copied this down. And we are going to do these 5 different types. So we will start with divergent, ocean, and ocean. So here's my question. If I have graham crackers and fruit roll-up, which one's going to represent grandma and which one's going to represent Billie Eilish, our oceanized, our oceanic crust? So which one's continental and which one's oceanic? I feel like this is Dora the Explorer. Which one is it? Answer. Okay. So, yes, great job. This one is continental crust because it's thicker. So grandma's thick. You know, she's got all that good extra pounds on her. And then Billie Eilish, young and thin, but dense. But grandma, thick, but brittle, but less dense because she's very wise. So the graham cracker is supposed to represent continental crust because it's brittle, y'all. It's going to break if it bashes into stuff. But it's a little bit thicker, but it's less dense. If I put this on water, it would float. Versus my fruit roll-up, like my my oceanic crust, Billie Eilish, it's young, it's thin, but it's more dense. It's more tightly packed. So this would, let's pretend this is more dense, which it really is more dense than this. But when I think of things that are more dense, I think of kind of sinking in water. So oceanic crust, continental crust. So if we have to do divergent, ocean, ocean, what are we going to use? We have to do divergent, ocean, ocean. What are we going to use? Yes, we're going to use the fruit roll-ups. So we are going to get set up. You can follow along in the PowerPoint that I linked, but I'm just going to kind of walk through it. So we're going to describe the movement and what direction the plates are moving. So if you have divergent, what's going to be happening? You are going to have 2 plates doing what? Moving apart. That's right. So we are going to put some pudding here. I'm going to kind of spread it out. So y'all, what does this pudding represent? The asthenosphere. Great job. It represents that kind of solid, kind of liquid, still has that plasticity on it. And then what we are going to do is we are going to not drop the pudding everywhere. Okay, y'all, so what we're going to do now is we are going to have our ocean crust and ocean crust diverge. So I'm actually going to take this half and I'm going to cut it in half again. So now I have 2 little pieces and I'm going to take them off the plastic. So what's going to happen is you are going to notice that as I am putting the 2 oceanic pieces, I'm going to put them on top of the pudding. 1 and 1. Now, what does divergent mean? It means the 2 plates are doing what? What does divergent mean? It means the 2 plates are coming apart. So we are going to record, my fruit roll-ups, y'all keep getting stuck to my trusty dusty journal. So we are going to record the description of the movement, what direction are the plates moving, and then we are going to draw our observations and talk about what features are formed. So as I am pulling these apart, you're going to notice that what is kind of coming up from that center? What is this stuff all coming up from the center? So you have that asthenosphere, you have that mantle kind of coming up from the center. And as it diverges or as it separates, you are going to have all that new magma coming up and you're going to have all that new seafloor being made. And then what's going to happen is, oh my God, y'all, these are so sticky. Y'all, so maybe don't use aluminum foil. Maybe y'all should use paper plates. So as it's separating, you're going to have all that new magma coming up. Then these are the older seafloor, and it's going to keep going until it's going to hit something else that's less dense, and it's going to go underneath and then get recycled. So when you have 2 oceanic plates separating, you have new magma coming up, and you have that new seafloor being made. I'm gonna pause for a sec so I can clean up. So y'all, I forgot to mention that this is going to make the mid-ocean ridge. So as it separates, you have that new seafloor coming up, that new seafloor being made, and that's going to create the mid-ocean ridge. Okay, y'all, so we are going to move down, and I tried to color code for you. I know it's hard to see, but we did divergent, and we're gonna do another divergent. I kind of circled it in green. So we're gonna do continental, continental, divergent. So I have my 2 continental plates, which is my graham crackers, because they're thicker, they're more brittle, they're less dense, like grandma, because she's old and wise. So we're gonna put these 2 here. And then what does a divergent boundary look like? What is it doing? Is it coming together? Is it colliding? Or is it going apart and dividing? Great job, separating, dividing. So same thing, y'all, as I separate my 2 continental plates, you notice the same things happening. I have that kind of separation, and this is creating a rift valley. So when 2 continental plates separate, you end up with that rift valley because you don't have all that hot magma coming up because it's not on the ocean floor, it's on top of the ocean. So then you're gonna have a rift valley when your 2 continental plates come apart. Let me pause so I can clean up. Hey y'all, have an edit for you, a little change. So y'all already have this down, so I want you to add this one on the bottom. Add convergent, ocean, ocean. And if you want, y'all, I'm getting pudding everywhere. If you want, you can draw those lines as well to kind of give you your columns. So type of plate boundary, we're gonna add convergent, ocean, ocean. And then this middle column, you're gonna describe the movement. What are the plates doing? What direction? And the last column is gonna be the same, your observations. So y'all, I forgot to have you add this one at the bottom. So we're gonna do that one next. So let's do convergent, ocean, ocean, and we're also gonna do convergent, continental, continental. So convergent, ocean, ocean, what are we gonna do? What pieces? Are we gonna do our fruit roll-ups? Or are we gonna do, oh, so gross. Our fruit roll-ups, or are we gonna do our graham crackers? If we are doing continental, continental, we're gonna do our graham crackers, right? Because it's less dense, thicker, and more brittle. So we are gonna converge continental, continental. So here is my asthenosphere, my pudding, and I'll do them this way, y'all. So if we are converging 2 continental plates, 2 brittle, less dense plates, what's gonna happen is they are literally gonna buckle like that and they are gonna fold up. And then they're gonna make mountains just like that, y'all. Ew, it's so gross, y'all. They're gonna make mountains just like that. So they're gonna buckle up. This is a hot mess, y'all. So I'll do it again with these little pieces. We're gonna put them together, and since they're the same density, they are going to buckle up like this, and they are going to make folded mountains. So for real, y'all, I need to pause because I need to straight up. Okay, y'all, so let's try this again. I got a cutting board instead, so I hope this is a little bit better. So we have our continental, continental, and we are gonna converge. So we're doing continental, continental converging, and then we are going to do converging ocean, ocean. So remember, my continental plates is my graham crackers. So when they ride across the top of the asthenosphere, our plates, they're gonna come into contact and they are going to buckle up just like this. So these are called folded mountains. Since they're both the same density, they're both literally going to crack, buckle up, and create folded mountains, something like that. Folded mountains. Now, if I have my fruit roll-up, which I'm going to get some new pieces because my other pieces are super gross and super sticky. Now, what does this represent? Continental or oceanic? That's right, oceanic, because they are thin, they are more dense, they're more tightly packed, they're not brittle. So I'm going to have my 2 oceanic crust here and here. And then I'm going to converge these. So what happens is they come together. See how one kind of goes underneath the other one? That's because one has to be more dense than the other one. So whichever one is more dense is going to go underneath. Okay, y'all, so it's kind of hard to see, but what's going to happen is the older crust is going to subduct underneath. So the older ocean crust is going to go underneath, and then the younger crust will go on top. And what you'll end up with is this deep ocean trench. Like, for example, the Marianas Trench. And then that's what's going to happen when you have two oceanic plates kind of converging. The older one is going to go underneath, subduct, and you're going to end up with that deep Marianas Trench. That one doesn't work as good as the other ones, y'all, to be honest. And then we're going to come here, and now we're going to do Convergent Ocean Continental. So this one is the one that actually works really good. So you're going to have your continental crust, and then I'm going to have my oceanic crust, which is my oceanized, my fruit roll-up. So I have this one here, and then I have my continental on the top. So what happens is, as I push these over, y'all, the graham cracker is less dense, so it is literally going to ride across the top. And then the oceanic crust is going to subduct underneath that continental crust. So take a minute and fill out your sheet, and I want to know what y'all think is going to form when this fruit roll-up subducts underneath this continental crust. So notice how I push them together, and notice how the continental crust rides right over on top because it's less dense. So I'm going to pause, and I want y'all, with my sticky pudding fingers, to be filling out what kind of movement is convergent right here, and then what is going to happen, what landform, what features are going to form when you have oceanic and continental converging. Okay, y'all, did you think about it? So what do you think is going to happen? So you're going to have a subduction zone, yes. This oceanic plate is going to subduct under the continental plate, and it's going to get destroyed, and it's going to get super hot, and it's going to be recycled back again, eventually up through, like when we did our two oceanic plates, that diverged, and that asthenosphere comes up and creates new crust. So the same thing, y'all, is going to happen when this continental plate collides with this oceanic plate. It's going to go on top, and this oceanic plate's going to subduct into this ooey gooey mantle, and it's going to be recycled into brand new oceanic crust. And then what you're going to have is you're going to have a trench volcano. So as this comes up, this piece is going down. It's agitating all of this kind of mush, and you're going to end up with a volcano. Okay, y'all, you don't even want to know what my mouse pad looks like. It's so gross. Okay, y'all, so we are going to do the last one. We are going to do transform boundary, and we're going to do continental for transform because continental plates slide past each other. And we're going to talk about which one happens, which land feature happens, y'all. So some of these, like I said before, some of these demos are better than others to actually visually show. For example, this first one is really good because it shows the two fruit roll-ups separating and that pudding or that magma coming up. Another one that's really good is this one, when you have the convergent, oceanic, and continental. If you think about a fruit roll-up and a graham cracker coming together, you know that the fruit roll-up is going to be more dense, and that one is going to subduct right underneath. So like I said, y'all, this one is a really good example. And this is mainly why we do this lab, because if you have the oceanic and the continental is less dense, that graham cracker is less dense, and it is going to slide right over that fruit roll-up. And not only that, y'all, these are just good visuals, that this is going to be like the oceanic crust because it's thin, it's dense, it's tightly packed, it's not brittle, it's kind of stretchy and plastic a little bit. And then this is a really great representation of continental crust because it's thicker, it's brittle, it's going to fall apart, and it's less dense. So like I said, y'all, even though we're getting a little messy, these are some really great kind of visuals. So the divergent fruit roll-ups separating is a great visual, and then the fruit roll-up going underneath that graham cracker is a great visual. So also when we converge our continental, so when we have our two continental plates or our two graham crackers coming together, they are going to buckle up or fold, and you're going to end up with your folded mountains. So those are some really great examples. And now we're going to show you the last great example, which is going to be transform boundary. And y'all down here, converge, ocean. If you have your two fruit roll-ups coming together, we talked about that before. It's a little messy now, but you're going to have that older one is going to subduct underneath. So you have your fruit roll-up and your other fruit roll-up, And as they converge, you're going to have that kind of deep ocean trench. So now this is another really great example. The reason I'm saying this, y'all, is because a couple of them, you got to use your imagination, but a couple of them are really, really great demonstrations. For example, this one. So you're going to have your graham crackers, and you're going to have kind of the rough edges together, so where you broke it. And y'all can see, like, you got all these dips and bends. As I run my finger across it, it's a really great representation of continental crust. So as I put these here, I'm going to kind of offset them a little bit. And then I'm literally going to grind them. And y'all, it's literally getting stuck. Like I'm pushing not super hard, but it's getting stuck. And that is a great representation of what happens when you have two continental transform fault line boundaries. Because what happens is it gets stuck and that pressure kind of builds up and then all of a sudden it slips. So sometimes they're called transform slip faults. It slips and then it shakes. So if y'all see when I do this, it shakes, and then the graham crackers shake. So what do you think, what kind of feature is going to happen at a fault line when I'm rubbing these together and trying to push them past each other? So take a minute to write down right here, when you have transform boundaries, what direction are they moving and what kind of feature is going to happen? So pause me and tell me what you think. Great job, y'all. You're going to have an earthquake. Okay, y'all. That was fun. I'm not going to lie. I'm going to pick all this up, but if you're doing it at home and you want to eat it, chocolate, graham crackers, and pudding? Chocolate pudding, graham crackers, and fruit roll-ups? You give it a try, y'all. I hope you had fun with our snack tectonics. If y'all could, down here, draw a picture of the models below. I'm going to post my notebook page with some more detailed notes because I know this was a little bit, you had to use your imagination a lot. So I'm going to go clean up and I'll see y'all later. Bye. You fill my buckets each and every day. Y'all, real quick. So I want to show y'all some notes so that way you can hit pause and you can kind of check this out. So we talked about oceanic. So you're going to have seafloor spreading, which means you're going to have new crust being made. And that asthenosphere, that mantle, is going to come up through that ocean floor that is diverging. And that's going to result in the mid-ocean ridge, which is where new seafloor firms. New seafloor firms. So new seafloor y'all. New seafloor forms. So right here in the center, new seafloor, and the further away you get, you're going to have older seafloor. And then eventually it's going to hit a less dense piece of ocean floor, and that's going to subduct. So it's like a nonstop conveyor belt. Then at the bottom, you have two continental diverging, separating, and you're going to have a rift valley because you're not going to have that magma kind of coming up when it's the continental crust. Okay. Then I'm going to show you all these ones. So you have convergent, which means coming together. You have your oceanic and your continental crust. So remember, oceanic crust is more dense, so you're going to have that one subducting underneath. So notice how we have the dotted line to show that it's subducting underneath. Then you're going to have a volcanic trench or trench mountains because you're going to have that fruit roll-up subducting under that graham cracker, and it's going to create a trench, and then you are going to have magma coming up, and that's going to make a volcano. Okay. Then we have this one, which is convergent, coming together, your continental, so the two pieces of graham cracker, and they're going to fold and buckle, and you're going to have those folded mountains, which are going to be non-volcanic, which is different than when you have oceanic and continental subducting, you're going to have your volcanic islands or your volcanic mountain range. So when you have just the two continents coming together, you're going to have a folded mountain range, much like the Himalayan mountains. Then if you have two oceanic plates converging or coming together, the older oceanic crust would subduct under the younger one. And you're going to have a deep ocean trench, like the Marianas Trench. And then last but not least, you have your transform boundary, which is the continental sliding past each other. And that's going to result in an earthquake because you're going to have that pressure build up as they slide past each other, and then that's going to result in an earthquake or a fault, which is a large crack or break in the crust, much like the San Andreas Fault in California. So I'll show each of these if you want to hit pause, or I will attach them as files, so that way you can download them and copy them. Okay, adios, au revoir, namaste, sai chen, auf Wiedersehen.